Today's topic, warp drives. Hello and welcome to AsteronX, researching and discussing things of science and space. Thanks for stopping by. I'm Todd, your host. Of course, there's nothing new about the concept of a warp drive. Thanks to Star Trek in particular, we know it well.
Warp drive, Mr. Scott. Ahead warp 1, Mr. Sulu.
Accelerating to warp 1, sir.
And of course, science fiction has inspired many a scientist to explore new technologies. Hence, we have lasers, cell phones, rockets, and more. Not only that, we all know sooner or later routine flights to and from space will become commonplace. In fact, one day, some of you watching this video right now, within the next 10 years, may actually be going to work in space. And when that day comes, we are going to be awestruck at just how vast space really is. Even though we already know this, once we actually begin venturing out there, experiencing it firsthand, it's going to be a real eye-opener. Let's face it, space is really big. With the current level of space tech, it would take us decades to reach Alpha Centauri. Farther out, hundreds or even thousands of years. Another galaxy, well, longer than the Earth will be around. Obviously, long-distance manned space travel is not really available to us if all we have are conventional rockets. They're just not going to get us far enough, fast enough.
1, 0, and liftoff of Space Shuttle Atlantis.
Other than conventional rockets or Ford Pintos with nacelles, is there a better way to reach for the stars? I'm sure there is, and that's exactly what we're about to discuss. There may be a multitude of ways, but none will be as fast or as practical as the warp drive. Now, we're already aware of warp drives in science fiction, but what about real warp drives? What do we know about those? Well, with recent discoveries plus what we already know, our understanding and technical abilities are now advancing at, well, light speed, so to speak. You could say our world is slowly becoming more like that of science fiction.
Warp 1, sir.
Heading, sir?
Out there. That way.
So this now brings me to where the warp drive ball picked up momentum. Dr. Miguel Alcubierre, an accomplished mathematician with an interest in Star Trek and their warp drives, actually put thought to the concept and in May of '94 published a paper entitled The Warp Drive Hyperfast Travel Within General Relativity. In this paper he describes a faster-than-light drive that warps spacetime in such a way as to allow the drive to exceed light speed without all the problems associated with going that fast. Without such a drive, it would be physically impossible to exceed light speed. Fortunately, he laid the mathematical foundation for future real warp drives. Unfortunately, his concept had several holes in it, one of which was the drive's huge energy requirement, requiring the mass energy equivalent of the entire universe in the form of very dense, negative exotic matter. Several years later, a few smart scientists at NASA decided to see if they could reduce the drive's energy requirement. And that's exactly what they did, bringing the concept that much closer to the realm of possibility. Around 2003, Dr. Harold White of NASA's Eagle Works Laboratories was asked to get involved. After much analysis, rethinking, reworking, and experimenting, he managed to not only reduce the drive's energy requirements further still, but he also managed to illustrate the potential feasibility of the concept. And as a result, in 2011, White published his own papers entitled Warp Field Mechanics 101, later followed by another entitled Warp Field Mechanics 102. You could say that he was thinking outside the bubble, to explore new ideas, to boldly research where no propulsion has been considered before. Excuse me, got a little carried away there. Well, anyway. In these papers, he outlines an updated, more refined version of Alcubierre's FTL drive, including a method to potentially prove the feasibility of the drive using an interferometer similar to the one they used to detect gravitational waves. Now, Alcubierre's drive was not really meant to be entirely practical or feasible, especially since it made use of a very dense negative exotic matter, nor is there any means of controlling the drive. Conversely, White's concept not only makes use of positive normal matter, but it also is easily controllable. Both drives work by generating a negative outward pressure on spacetime in all directions. With White's concept, this is achieved by means of a high-frequency oscillating torus, whereby the intensity of the energy is oscillated, so the amount of energy in the torus is alternately increased and decreased repetitively. Since there seems to be no speed limit as to how fast spacetime can be contracted and expanded, it should therefore then be possible to affect spacetime in any desired manner. Now this is where things really get interesting. The action of oscillating the warp ring, 1. Softens spacetime, which is very stiff. 2. Creates a spherical warp bubble of spacetime, effectively separating internal spacetime from external spacetime. 3. Creates a flat or calm region of spacetime at its center, which conserves local spacetime so that the spacecraft never really exceeds light speed within the bubble's spacetime frame of reference. 4. Reduces the energy required to warp spacetime drastically. 5. Pushes the bubble and anything within it into a higher dimensional spacetime or hyperspace. 6. Multiplies the bubble's speed as a result of all the above, which 7. Allows the drive to exceed light speed by screening away spacetime dilation distortion. The reason for why oscillating the torus and thus spacetime softens spacetime is similar to that of an oscillating diamond tip drill, whereby the stone gives way freely, easily. Oscillating a spherical bubble of spacetime causes spacetime to likewise give way freely, more easily. Since both space and time are involved, this means that there's always going to be a higher dimensional effect. According to White, if you go far enough into hyperspace, you would cease to interact electromagnetically with anything and everything. Does this mean then that if you go fast enough, far enough into hyperspace, you would effectively break away from our four-dimensional plane? Interesting, something to consider, isn't it? One thing I want to mention, anytime you go into a higher dimensional plane, you are effectively increasing your rate of time, your frame of reference. It is this that causes you to apparently fast forward, as White was stating. As you can see, there's nothing complicated about a warp drive consisting of a pulsed ring, or torus. What's complicated is in the way the drive warps space-time. So does this mean that warp drives are actually feasible? Well, both the math and experimental data supports the concept. Experiments are telling us that something very interesting is indeed taking place. We're just not yet familiar with what is taking place. So technically, it would seem that the answer is a yes. There is sound evidence that supports the validity of a warp drive, such as inflation observed in the cosmos, the Casimir effect, negative mass, space, pressure, general and special relativity, the warping or distorting of spacetime, the Chung-Freeze mathematical metric of higher dimensions of spacetime, the recent detection of gravitational waves, and much more. Each new discovery is paving our understanding and way towards us becoming a spacefaring world. I'm sure that within the next 5 to 10 years, we will be amazed at what we can do. As a side note, if everyone was employed, had money to spend, whether working in space or on Earth, wouldn't our economy be hugely successful? Will we be using warp drives in the future? Absolutely. It may not be exactly like the Alcubierre White drive, but I have no doubt that we will be using something like a warp drive. In fact, I would venture to say that the majority of us alive today will actually get to see one roll out onto the departure pad, so to speak. Even within White's concept, there are a few questions that need to be satisfied before we can begin designing, constructing, and operating one. That said, in another video, I'll be trying to satisfy some of those questions about White's concept and perhaps propose a few of my own. Basically, we already possess the technology to nearly construct one. However, operating one is an entirely different matter. It's far too dangerous. We're going to need other technologies and know-how first. Traveling through space is not much of a problem if you're small, slow, and unmanned. But when we start sending out manned missions deep into space at higher speeds, we're going to encounter hazards we're not yet ready for. Such as, even at just 10% the speed of light, mere gas and dust will be a threat to our spacecraft, which means we're also going to need active shielding 24/7 from the moment we start venturing out there. These are only technical issues which can be worked out and will be worked out. In fact, we need scientists and engineers to start working on these things now before we get out there. Is it possible for us to develop the needed technologies within the next 10 years? You bet it is. Interestingly, if all we did right now was assemble what we already know, plus what we're discovering, we would be amazed at what we already know and can do. Well, that concludes this video. Thank you for watching. Be sure to watch out for our upcoming videos. Till then, keep wondering about space.